Hey guys, tonight we are going on a journey, a very strange and impossible journey. We'll be traveling to a place where the rules of the universe as we know them begin to unravel, a place where gravity bends and time itself becomes a river curving and swirling around colossal cosmic monuments. But a fair warning, this is not a journey you could survive in your physical form. Your body would be torn apart by tidal forces beyond comprehension, and your mind would struggle to hold on to its own sanity as the very fabric of reality twists. It's a place best visited in the quiet of your mind, in the gentle dark, before sleep takes hold. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Let me know where you're listening from tonight and what time it is there in your quiet corner of the world. And now, let's begin our impossible voyage. Imagine a river. Not the gentle meandering stream you might see flowing through a quiet valley, but a vast cosmic river, the river of time itself. For us here on Earth, time feels like a straight and steady current, a predictable flow from one moment to the next. But in the grand tapestry of the cosmos, this river is anything but straight. It's a living, breathing entity, and its flow is profoundly influenced by the very things that inhabit its banks. The heaviest objects in the universe are like enormous boulders in this river, causing the current to slow and bend around them. This is the core of Albert Einstein's theory of general relativity, the beautiful poetic idea that mass and energy warp the very fabric of space-time, the interwoven tapestry of space and time. This warping is what we perceive as gravity. We don't feel a pull from a massive object. Rather, we are simply following the shortest, most natural path through this curved space-time. The Earth isn't being pulled by the sun. It's simply rolling along a gentle slope in the fabric of reality that the sun has created with its immense mass. These cosmic boulders are everywhere. Our sun is one, albeit a relatively small one. Its mass gently curves the river of time, causing the planets to orbit within its gravitational well. If you were to stand on a planet closer to the sun or on a star, you would age ever so slightly slower than someone on Earth, an effect known as gravitational time dilation. The closer you get to a massive object, the more the river of time slows down for you. This isn't just a theoretical concept, it's a measurable fact. The atomic clocks on GPS satellites in orbit run slightly faster than those on the ground, and their calculations must be constantly corrected for this effect to ensure your phone can pinpoint your location with accuracy. It's a subtle whisper from the universe that time is not an absolute constant, but a malleable dimension, a fabric that can be stretched and compressed. But what if we were to find a boulder so massive, so incredibly dense, that it didn't just slow the river of time but brought it to a complete halt, creating a whirlpool from which nothing, not even light, could escape? This is the heart of our story, the genesis of our first main character, the black hole. A black hole is born from the death of a supermassive star, a star that burns so brightly and so fiercely that it eventually runs out of fuel and collapses under its own immense gravity. This collapse is a cosmic final breath, a stunning supernova explosion that leaves behind a core of unbelievable density. At its center lies a singularity, a point of infinite density and zero volume, a place where our known laws of physics cease to function. Surrounding this singularity is the event horizon, a boundary of no return. The event horizon is not a physical wall. It's a conceptual sphere in space-time. Think of it as the edge of that cosmic whirlpool. Cross that line, and the river of time rushes inward so fast that it becomes impossible to escape. The speed required to get away would have to be greater than the speed of light, which, as we know, is the ultimate cosmic speed limit. A black hole is, in essence, a cosmic drain, a one-way street where everything matter-energy light falls in and never comes out. We have even managed to photograph the shadow of a black hole, the Event Horizon Telescope project, providing us with a stunning image of the supermassive black hole at the center of the galaxy M87. This is no longer just theoretical science. It is a tangible, albeit terrifying reality. Now let's talk about its inverse, its theoretical mirror image. If a black hole is a one-way street in, what if there was a one-way street out? A place where nothing could ever enter and matter and energy were constantly being spewed forth. This is the concept of a white hole, a purely theoretical object, where a black hole is a sink, a white hole is a source. While a black hole is the collapsed remains of a star, we don't really know how a white hole could even form. It doesn't have a known physical process. It's an elegant mathematical solution to the equations of general relativity. But it doesn't have any physical evidence to support its existence. A white hole would also have an event horizon, but its nature would be entirely different. While the black hole's event horizon is the point of no return for things entering the white holes, would be the point of no return for things trying to stay outside. Things would be violently ejected from it. To an outside observer, a white hole would look like a star that just never ever ran out of fuel, a beacon of light and matter bursting forth forever. This is the great beautiful paradox we must hold in our minds tonight. We have a black hole, an insatiable cosmic mouth that consumes all. And we have a white hole, a theoretical cosmic fountain that gives all. One represents the ultimate end, the other, the ultimate beginning. One is a state of cosmic imprisonment, the other a state of cosmic liberation. They are the two sides of a coin, the ultimate yin and yang of the universe. The black hole represents the crushing weight of gravity, the ultimate finality. The white hole, in its theoretical perfection, represents the ultimate creation, a relentless cosmic outburst. And as we drift deeper into this thought experiment, we must ask ourselves, what would happen if these two impossibilities, these two perfect opposites, were to collide? The laws of physics, as we understand them, tell us that such a collision is impossible. A white hole is in essence the time-reversed version of a black hole. If you were to take the equations describing a black hole and run them backwards in time, you would get a white hole. This is the great mystery. In the universe we inhabit, time only flows in one direction, a phenomenon deeply connected to the concept of entropy. Entropy is, in simple terms, a measure of disorder. The second law of thermodynamics states that entropy can only increase over time. A black hole increases the entropy of the universe by taking in matter and energy and making its disorder inaccessible. A white hole, by spewing out matter and energy, would seem to be decreasing entropy, a direct violation of this fundamental law. This raises an interesting philosophical question. Are these two concepts so mutually exclusive that they could never exist in the same universe in the same moment? The truth is, we don't really know for sure. The very idea of their coexistence breaks our most basic understanding of the cosmic order. So when we imagine this collision, we are not just imagining two colossal objects meeting. We are imagining the clash of two fundamental concepts of physics, two opposite flows of time, two perfect mathematical constructs that should by all rights be strangers to one another. Their approach would be a cosmic ballet of incomprehensible forces. The black hole would pull with a gravitational force so immense it would tear apart the fabric of space-time itself. The white hole would push with a repulsive force, a cosmic pressure that would fight against the black hole's pull with equal but opposite intensity. What would this look like? Would they simply cancel each other out in a flash of nothingness? Or would their meeting be a cataclysmic event that reshapes reality in ways we cannot begin to fathom? This is not a collision of two stars. It's a collision of a cosmic sink and a cosmic source, the devourer and the giver, one trying to pull everything in the other, trying to push everything out. The forces at play would be so immense that even the concept of space would struggle to hold its shape. The river of time we spoke of earlier would no longer be a gentle curve or a simple whirlpool. It would be a raging maelstrom, a hurricane of reality that could tear the very moments of existence into pieces. This journey begins in the quiet imagination in the deep silence of space, where two entities that should never meet begin their slow, inevitable approach. This is a story about the rules of the universe being tested, bent, and possibly utterly broken. It's a story about two theoretical singularities, one of which we know exists, and the other, which we can only dream of. The black hole and the white hole are not just cosmic objects. They are philosophical concepts made real, and their collision is a thought experiment about the very nature of existence. This journey will take us to the edge of what we understand and beyond. And so, with a quiet breath, we begin. We left our quiet corner of the universe, our minds drifting towards the impossible encounter of two cosmic titans. But to truly understand their collision, we must first get to know them intimately, to peer into their separate, solitary lives. Let's begin with our familiar friend, the black hole. Its story is one of spectacular death and rebirth, a tale of a star that lived its life in a blaze of glory before collapsing into a profound, silent nothingness. Imagine a star, a colossal sun, 100 times more massive than our own. For millions of years, it burns with a fierce, brilliant light, a constant nuclear furnace fusing hydrogen into helium and then heavier elements. It lives a life of immense pressure and temperature, a perfect balance between the outward push of nuclear fusion and the inward pull of its own colossal gravity. It is this delicate dance that keeps it stable, a fiery sphere floating in the cosmic dark. But even the mightiest stars must die. Eventually, the star's core runs out of fuel. The fusion stops. Suddenly, there is nothing to push back against the crushing weight of gravity. In an instant, that delicate balance is shattered. The star begins to collapse inward on itself with unimaginable speed, a process so violent it creates a shockwave that blows the star's outer layers into space in a brilliant supernova explosion. This cosmic firework display is one of the most powerful events in the universe, briefly outshining entire galaxies. What's left behind is the star's core, a remnant of its former self. If this core is massive enough, at least 3 times the mass of our sun, the force of the collapse is so great that nothing can stop it. Not even the repulsion of atomic nuclei can withstand this pressure. The core shrinks and shrinks, crushing all matter into an infinitely small, infinitely dense point. This is the singularity, the heart of the black hole. And around this singularity, a sphere forms, a sphere we cannot see, but whose presence we can feel profoundly. This is the event horizon, the point of no return. We spoke of it as a river's whirlpool, and that metaphor holds true. But let's refine it. Think of the event horizon not as a physical barrier, but as a place where the escape velocity, the speed you need to travel to break free from gravity, exceeds the speed of light. Light, the fastest thing there is, the very messenger of information, cannot escape. This means that once something crosses this threshold, it is gone forever, not just from our sight, but from our universe. The arrow of time for an object crossing the event horizon points inexorably towards the singularity. It's a one-way street, a door that slams shut forever. To an observer outside the event horizon, a person falling into a black hole would appear to slow down and freeze in time, their image reddening and fading until it is no more. This is due to the extreme time dilation at the edge of the black hole, a subtle, eerie testament to the way gravity distorts the very passage of time. This one-way nature of the black hole is a key characteristic. It is an endpoint. It is a cosmic prison where matter, energy, and information go in, but can never come out. The concept of information paradox in black holes is one of the most profound and perplexing mysteries in physics. When matter falls into a black hole, is the information contained within it, the arrangement of its atoms, the history of its past truly destroyed? Our current understanding of quantum mechanics suggests that information can never be truly lost. So where does it go? Does it get stored on the event horizon itself, or does it somehow, in a way we don't yet understand, escape? This is a question that physicists like Stephen Hawking have wrestled with for decades, and the answer remains elusive, a great unknown at the very heart of the black hole's nature. Now let us turn our attention to the great mystery, the theoretical counterpart, the white hole. If the black hole is a door that only opens inward, then the white hole is the opposite, a door that only opens outward. In the mathematical universe of general relativity, white holes are simply the time-reversed solutions of black holes. If you were to watch a film of a black hole forming and consuming matter, and then play that film in reverse, you would see a white hole. In this reversed film, a massive object would spontaneously burst forth from a singularity spewing out matter and light. It would be a source of constant creation, a fountain of everything. The white hole also has an event horizon, but its purpose is inverted. It is a boundary that no external matter can cross. You could not fall into a white hole. You would be violently and powerfully repelled from its surface. Everything within the white hole's event horizon is destined to be ejected to burst forth into the wider universe. It's a cosmic cannon, a source of light and energy that would seem to defy the very laws of thermodynamics. How could something be constantly spewing out energy without having a source to fuel it? How could matter be created from nothing? These are the questions that make white holes so beautiful and so impossible. They violate the second law of thermodynamics, the idea that entropy or disorder can only increase in the universe. A white hole would be a perfect machine of order, constantly decreasing the entropy of its surroundings by creating and pushing out organized matter and energy. This is a crucial distinction between the two. The black hole is a force of order moving towards disorder, a devourer of complexity. The white hole would be a force of disorder moving towards order, a creator of complexity. They are two sides of a coin, but the coin itself might not exist in this universe. This brings us to a fascinating and slightly strange scientific fact, one that underpins the sheer impossibility of our thought experiment. Remember how we talked about a black hole's event horizon being a one-way street? An object that crosses the event horizon is on a path that can only lead to the singularity. But from an observer's perspective, the time of the falling object appears to slow down, and it never truly crosses the event horizon. This creates a paradox. We know that, in its own frame of reference, the object does indeed cross the event horizon. Yet, to an outside observer, it never does. This is known as the twin paradox in a black hole's gravitational field. A twin who stays far away will see their sibling freeze at the event horizon and never truly fall in, while the falling twin would have no trouble crossing the event horizon and reaching the singularity. The white hole, if it existed, would likely have a similar inverted paradox. An observer far away would see matter emerging from its event horizon, but the matter itself would have been inside for an infinite amount of time. So now we have our two players fully defined in their separate solitary realities. We have the black hole, the great devourer, a cosmic tomb, and we have the white hole, the great giver, a cosmic cradle. One is a reality we have measured and photographed. The other is a beautiful, elegant mathematical fantasy, a ghost in the equations of general relativity. The black hole is the embodiment of the end of all things. The white hole is the embodiment of the beginning of all things. The story of a black hole is a testament to the immense power of gravity and the finality of stellar life. The story of a white hole is a testament to the boundless imagination of physicists, a dream of a universe that can create as well as it destroys. The stage is set, the two impossible beings are on their separate paths, and we are left to wonder what happens when a door that only opens inward meets a door that only opens outward. This collision is not just an event. It's a profound question about the very nature of existence, a query whispered into the silent dark of space. We have now sailed through the dark waters of the black hole's life and dipped our toes into the impossible cascade of the white hole. Our journey so far has been one of stark contrasts. A cosmic tomb versus a cosmic cradle, a one-way street in versus a one-way street out. Now, as the distance between our two theoretical titans begins to shrink, we must turn our full attention to the ghost in the machine, the phantom of the cosmic equations, the white hole. Remember that a black hole is a real observed phenomenon. We have seen its gravitational effects, and we have even managed to photograph its shadow. It is a creature born of the universe's laws, an inevitable conclusion to the life of a massive star. A white hole, however, is a different kind of entity altogether. It is not born from a physical process we understand. It is, to put it simply, a theoretical time reversal of a black hole. Imagine a film of a black hole's life played in reverse. Instead of matter falling in and being crushed, we would see matter and energy erupting from a single point in an endless torrent. This is the essence of a white hole. It is a mathematical possibility, a ghost that haunts the equations of general relativity, but one for which we have no physical evidence. It exists in the realm of pure thought, a beautiful, impossible idea. The core distinction between the two lies in their event horizons. The black hole's event horizon is a boundary that can be crossed in one direction, only inward. It is a point of no return for anyone or anything that crosses it. The white hole's event horizon, in contrast, is a boundary that can be crossed in one direction only outward. Nothing can enter a white hole from the outside. Anything that tries would be violently repelled by an immense force, a cosmic pressure that pushes against the very fabric of space-time. This is the ultimate keep out sign of the universe. The inside of a white hole is a region of space-time from which matter is inexorably ejected, not consumed. So what might a white hole look like to an outside observer? It would be a breathtaking sight, a cosmic geyser of creation. We would see a source of immense light and energy, perhaps even matter erupting forth into the void. It would appear to be a kind of perpetual motion machine, an energy source that never runs out. It would defy the conservation of energy, and more importantly, the second law of thermodynamics. The second law, in its simplest terms, states that the total entropy or disorder of an isolated system can only increase over time. A white hole, by constantly creating and spewing out ordered matter and energy, would be a cosmic anomaly, a machine of perpetual creation that would violate this fundamental law. This is a primary reason why most physicists believe white holes cannot exist in our universe. Our universe, it seems, is built for increasing disorder, for things to fall apart, not to spontaneously come together. But what if, just for a moment, we allow ourselves to entertain the impossible? What if a white hole could exist? This is where our story truly begins to bloom into a beautiful tapestry of philosophical and scientific wonder. Some theories suggest that a white hole might not be an independent entity at all, but rather the other end of a black hole. This concept, known as a wormhole, is another purely theoretical solution to the equations of general relativity. It proposes a tunnel through space-time, a bridge connecting two different points. A black hole in this model would be the entrance to the wormhole, and a white hole would be the exit. While this is a captivating idea, a journey through such a wormhole would likely be impossible. The very forces at play would tear apart any object trying to pass through, and the stability of the wormhole would be fleeting at best. Another, even more mind-bending idea is that a white hole could be connected to a completely different universe. Perhaps the matter and energy bursting forth from its mouth are not from our own universe, but from another, a place where different laws of physics might apply. This idea connects the white hole to the concept of the multiverse, the theory that our universe is just one of many, a single bubble in a vast cosmic foam. The white hole in this sense could be a birth canal for a new universe, or a point where a younger universe leaks its contents into our own. It's a tantalizing thought, a whisper of other worlds that exists just beyond the veil of our own reality. This also leads us to a fascinating scientific oddity known as the Novikov self-consistency principle. This principle, applied to time travel, suggests that if a time machine were to exist, it would be impossible to create a paradox, such as going back in time to kill your own grandfather. events in a closed loop of spacetime would have to be self-consistent. The white hole, in its time-reversed nature, presents a similar paradox. If a white hole is a time-reversed black hole, could it be that the matter and energy it expels are not new, but are simply the matter and energy that fell into a black hole in the future, traveling back in time through some cosmic mechanism? This creates a perfect yet impossible self-contained loop, where a black hole and a white hole are not just connected, but are one and the same entity existing in two different points in time. The existence of a white hole is at its heart a profound question. We know that the black hole is a force of cosmic destruction, a powerful and final end. But what is a white hole? Is it a force of creation? Is it a glimpse into another universe? Is it a key to understanding the nature of time itself? Physicists still wonder if the universe has a place for such an object. The truth is, we don't really know for sure. It is a hypothetical entity, a beautiful puzzle with missing pieces. And as we now bring our two players closer together, the known and the unknown, the possible and the impossible, we are not just observing a collision of physical objects. We are observing a philosophical clash, a confrontation between two opposing ideas, finality and perpetuity. The black hole and the white hole are like two poets, one writing a poem about the end of all things, the other writing a poem about a constant, beautiful beginning. And as they get closer, their verses begin to intertwine, their stories begin to merge, and we are left to wonder what new poetry will be born from their meeting. The stage is set. We have our two magnificent, impossible characters. The black hole, a one-way door to nothingness, a place of ultimate consumption, and the white hole, a theoretical one-way door from nothingness, a place of ultimate creation. In the quiet theater of our minds, these two forces, these two opposing concepts, begin their slow, inevitable approach. The black hole, a silent void, is defined by its insatiable hunger. The white hole, a cosmic firework, is defined by its furious repulsion. What happens when the insatiable hunger meets the furious repulsion? This is the core question of our entire journey, the vortex that will pull us deeper into the realms of the impossible. The very idea of their collision is a profound violation of our known physics. It is the equivalent of trying to multiply a number by zero and infinity at the same time. Remember how we talked about the event horizon of a black hole being a one-way street, a point of no return for anything that falls in the white hole, has an equally defined but opposite event horizon, a boundary from which everything is violently ejected and which nothing can enter. So when these two objects begin to approach each other, their fundamental natures come into direct conflict. The black hole's gravity, its pulling force, would be immense. It would bend and warp the fabric of space-time around the white hole trying to pull it in. But the white hole, by its very nature, would be exerting an equally powerful but opposite repulsive force. It would be pushing against the black hole's gravitational pull with a ferocity that is hard to even imagine. This is not a simple collision of two massive rocks in space. It is a clash of two opposing forces of nature. The black hole's event horizon, the point of inward flow, would meet the white hole's event horizon, the point of outward flow. What is the result of a one-way street in meeting a one-way street out? The mathematical solution to this problem is a resounding paradox. The equations simply break down the rules we use to describe the universe. Einstein's theory of general relativity, the laws of thermodynamics, do not have an answer for this. It's like asking what happens when an irresistible force meets an immovable object. The laws themselves fail to provide a coherent outcome. This raises a fascinating and slightly strange scientific fact, one that underscores the sheer impossibility of our thought experiment. In the world of quantum mechanics, a black hole is not entirely black. Stephen Hawking theorized that black holes can slowly radiate energy, a phenomenon now known as Hawking radiation. This radiation is caused by quantum fluctuations near the event horizon. Imagine pairs of virtual particles and antiparticles constantly popping into and out of existence in the vacuum of space. Near the event horizon, one of these particles might get sucked into the black hole while its partner escapes. The escaping particle takes energy with it, causing the black hole to incredibly slowly lose mass and eventually, over trillions upon trillions of years, evaporate. A white hole, being a time-reversed black hole, would not emit Hawking radiation. Instead, it would absorb it. This means that a white hole, far from being a source of constant creation, would be a cold, dark entity that is constantly taking in energy from the universe, just like a black hole, but without a physical source for it. This is a profound contradiction, and it is a powerful argument against their existence. The truth is, we don't really know how a white hole would interact with the quantum world. The core concept that the collision would violate is the principle of causality. Causality is the idea that every effect has a cause, and that cause must happen before the effect. A black hole adheres to this principle perfectly. An object is pulled in by gravity and it falls in. Cause and effect are clear. A white hole, on the other hand, is a violation of causality. An object suddenly appears, a causeless effect. Where did it come from? We don't know. The white hole is a time-reversed solution, a place where effect happens before cause. So when these two objects collide, we have a situation where a cause and effect-abiding object meets a causeless object. The very fabric of causality, the very thing that makes our universe predictable and understandable, would be torn apart. This isn't just a clash of physical forces. It's a profound philosophical confrontation. It is a dialogue between the concepts of beginning and end of creation and destruction of cause and effect. The black hole says, all things must come to an end. The white hole says, all things must have a beginning. Their collision is a debate that transcends the physical and enters the metaphysical. What would it look like? Would they simply pass through each other as if they were ghosts? Would they annihilate each other in a flash of unimaginable energy, leaving behind a blank empty canvas of space-time? Or would their collision create a new kind of object, a hybrid of both a pulsating cosmic heart that devours and creates at the same time? The most probable and least dramatic outcome is that the black hole and white hole could not and would not ever occupy the same space. The moment the white hole's outward-pushing force met the black hole's inward-pulling force, they would create a region of space-time so unstable that it would simply cease to exist. The energy required to maintain both of these states simultaneously would be infinite, and the universe, in its elegant wisdom, does not allow for infinities. This is the ultimate paradox. The two concepts are so perfectly opposed that they cannot coexist even in a collision. Their meeting would be an instantaneous negation of reality, a cosmic cancellation, where the two titans simply erase each other from existence, leaving behind a quiet patch of space-time, a cosmic silence where a cataclysm should have been. But that's the rational physics-based answer, and tonight we are not here for the rational. We are here for the beautiful, for the impossible. We are here to ask what if? What if, instead of simple negation, something more poetic, more profound were to occur? What if the irresistible force and the immovable object, instead of destroying each other, were to merge, to combine their opposing natures into a single paradoxical entity? This is the journey we are on. A journey into the heart of a paradox, a descent into the beautiful madness of a universe that defies its own rules. The collision is no longer a question of physics. It is a question of storytelling. The stage is now set for a cosmic ballet, a dance of two impossible partners. We have the black hole, the great cosmic drain, a silent devourer born of gravity's immense power. And we have the white hole, the theoretical cosmic fountain, a fiery creator born of a time-reversed dream. The distance between them is now gone. They are a hair's breadth apart, their event horizons almost touching their opposing forces, locked in a silent, violent struggle. The black hole's gravitational pull, immense and unforgiving, stretches and tears at the fabric of space-time, trying to swallow its counterpart whole. But the white hole, with its equally immense repulsive force, pushes back with a furious intensity, a cosmic breath fighting against a cosmic inhale. This collision is not just an event. It's a cosmic paradox made manifest. The black hole's nature is defined by its hunger, its absolute finality. The white hole's nature is defined by its constant creation, its absolute beginning. When they meet, it is not a simple crash, it's a profound confrontation of two opposing natures. The black hole is a one-way street in, and the white hole is a one-way street out. Their collision is an attempt to create a street that goes in and out at the same time, an impossibility that would tear the very road of reality apart. The laws of physics as we know them would simply fail to describe what happens here. This is a place where the rules of cause and effect of thermodynamics and of causality itself become meaningless. Let's use an analogy to try and grasp this impossible meeting. Imagine a whirlpool in a river at a vortex that pulls everything to its center, and at the same time, imagine a powerful geyser erupting from that same spot, pushing everything away. What happens at the point where the water is being pulled in and pushed out with equal but opposite force? The water would simply cease to be water as we know it. It would become a state of utter chaos, a point of unimaginable turbulence, where the very concept of flow breaks down. This is what the meeting of a black hole and a white hole would be like on a cosmic scale. The river of time we spoke of earlier would no longer be a river. It would be a point of pure, unadulterated chaos. This brings us to a fascinating scientific fact about the nature of black holes that might give us a clue as to what happens here. Remember how we spoke about the Hawking radiation. In the previous part, the slow evaporation of a black hole. The white hole, if it existed, would be the time-reversed version of this. It would not radiate energy. It would absorb it. So, as the black hole's pull is trying to consume the white hole, its very essence, its outward pushing force, is fighting back. The white hole is an object that cannot be entered, and a black hole is an object that must be entered. The moment their boundaries touch, the universe must make an impossible choice. Does it allow matter to be pushed out and pulled in at the same time? The answer, according to our current understanding, is a resounding no. So what is the most likely outcome from a physicist's perspective? The most elegant and perhaps the most anticlimactic solution is that they would simply cease to exist. The meeting of two perfect opposites would result in mutual annihilation, not in a flash of light, but in a silent, cosmic erasure. The two entities are so perfectly contradictory that their coexistence, even for a moment, is a logical and physical impossibility. They would cancel each other out, leaving behind a quiet, empty patch of space-time where the cataclysmic event should have been. This would be the ultimate paradox, a place where a monumental event leaves behind no trace, a place where the universe simply closes the book on a theoretical impossibility. But again, we are not here for the cold, hard logic of physics. We are here to dream. What if their collision wasn't an act of negation, but an act of creation? What if instead of destroying each other, they were to merge into a single new entity, a creature of pure paradox, a cosmic heart that pulses with both creation and destruction, a being that devours and gives at the same time? Such a thing would defy all of our known laws. It would be a truly new type of object, a hybrid of a black hole and a white hole. It would be a kind of cosmic blender, a place where matter and energy are simultaneously pulled in and pushed out, a constant state of flux. This new entity would have an event horizon that is not a one-way street, but a two-way street. Matter could enter and matter could exit. But what would happen to the matter that enters and exits? Would it be the same matter? Or would it be a new form of matter, a kind of cosmic ghost that has been transformed by the paradox of its journey? This raises another interesting question. Could this new entity be a form of wormhole, A stable wormhole that instead of being a bridge between 2 points in space, is a bridge between 2 points in time. The matter that enters the black hole side would come out the white hole side, but at a different point in time, perhaps even in a different universe. This would be the ultimate time machine, a cosmic portal that not only takes you to a different place, but to a different moment. The story of the collision of a black hole and a white hole is at its heart a metaphor. It is a story about the meeting of two opposing forces, a dialogue between creation and destruction. The black hole is the finality of a chapter, the end of a long story. The white hole is the beginning of a new one, the first word on a blank page. Their collision is the moment between the last sentence and the first, a fleeting instant of pure potential, a time when anything and everything is possible. As they meet in the silence of our minds, they create a space where the rules of the universe are broken and a new kind of cosmic poetry can be written. And as we watch this impossible dance, we are left to wonder in this strange place, where creation and destruction are one and the same, what new reality will be born? The impossible dance continues, but our focus shifts from the chaotic core of the collision to the broader cosmic stage. What does this cataclysmic event, this clash of creation and destruction, mean for the universe at large? The most elegant and profound answer might be that this collision is not an end, but a beginning. It's a captivating thought that the white hole, this theoretical cosmic fountain, could be a point of cosmic genesis, a place where the universe itself is born. This idea suggests that our entire universe, with its billions of galaxies and trillions of stars, might have erupted from a single white hole-like event. This links our thought experiment to the most fundamental of all cosmic stories, the Big Bang. The Big Bang theory states that the universe began from an incredibly hot, dense state and has been expanding ever since. But what was that initial state? What was the cause of that magnificent explosion? The truth is, we don't know for sure. The physics of the moment of creation, the singularity at the beginning of time, is a mystery that has puzzled physicists for decades. The white hole, in its constant outward flow of matter and energy, provides a beautiful, if purely theoretical, answer. What if the Big Bang was not a random singular event, but the outward burst of a supermassive white hole? This idea, known as the white hole cosmology, suggests that the universe we inhabit is the interior of a massive white hole, and the Big Bang was the moment it began to expel its contents. This would mean that the constant expansion of our universe, the very thing we observe with our telescopes, is not the result of some mysterious force, like dark energy, but rather the natural outward flow from a white hole's event horizon. The event horizon of the white hole would then be our cosmic horizon, the limit beyond which we cannot see. The matter and energy that make up our universe would have been ejected from this point, and we are simply riding the wave of that initial cosmic burst. This raises an interesting and slightly strange scientific fact, one that is beautifully connected to our discussion of time. Remember the concept of gravitational time dilation, where time slows down near a massive object. If our universe is a white hole, then what would the outside look like? To an outside observer watching our universe expand, time would appear to flow incredibly fast. Our entire cosmic history from the Big Bang to the present day would unfold in a fraction of a second for them. This creates a profound sense of cosmic humility. Our billions of years of existence, our struggles, our triumphs, and our dreams are just a fleeting moment to a hypothetical observer outside our cosmic bubble. So when a black hole and a white hole collide, we are not just observing a physical event. We are observing a profound philosophical confrontation between a cosmic beginning and a cosmic end. A black hole represents the ultimate conclusion, the gravitational collapse of all things. A white hole in this theoretical framework represents the ultimate beginning, the fountain of creation. Their collision, therefore, is a moment where the end meets the beginning, a point where the cosmic timeline is bent into a loop. Could the matter that is pulled into the black hole be the very same matter that is being pushed out of the white hole, a kind of cosmic recycling plant. Could the end of one universe be the beginning of another? Physicists still wonder if a white hole could be a portal to another universe. This concept is sometimes called the Einstein-Rosen bridge, or a wormhole. A black hole would be the entrance, and a white hole would be the exit, connecting our universe to another. So when our black hole and white hole collide, they might not be colliding at all, but rather merging to form a stable wormhole, a permanent bridge between two realities. This would be a place where the laws of physics are not broken, but rather transcended, a place where matter and information could flow from one universe to another, from one beginning to another end. The truth is, we don't really know for sure. The concept of white holes is so deeply rooted in the theoretical that we are left with more questions than answers. Is a white hole the mirror image of a black hole? Is it a cosmic birth canal? Is it a key to understanding the Big Bang? Or is it simply a beautiful mathematical impossibility, a ghost in the equations that has no place in our universe? The collision of a black hole and a white hole, therefore, is a story about the boundaries of our knowledge. It's a story about what happens when we push our understanding of the universe to its absolute limit and beyond. It is a moment of pure, unadulterated wonder, a time when we can dare to dream of a universe that is stranger, more beautiful, and more paradoxical than we ever thought possible. Our impossible dance between the devourer and the giver continues. As we watch their event horizons meet their opposing forces, locked in a fierce, silent struggle, we must pause and consider the very nature of these forces. The black hole is the embodiment of a powerful inward pull. It is a cosmic vacuum cleaner, a well of gravity so deep that nothing can escape. The white hole, in contrast, is the embodiment of a powerful outward push. It is a cosmic geyser, a fountain of creation. This is not a simple game of tug-of-war. This is a clash between the very concepts of attraction and repulsion on a cosmic scale. Let's imagine for a moment what this looks like in the swirling maelstrom of space-time. Around the black hole, matter, gas, and light are drawn in, spiraling in a beautiful, deadly dance. This is the accretion disk, a flattened, rotating disk of material that has been captured by the black hole's gravity. Friction within this disk heats the matter to unimaginable temperatures, causing it to emit brilliant X-rays and other forms of radiation. The accretion disk is the final fiery tribute to the black hole's insatiable hunger. Now let's imagine a white hole. A white hole would have the exact opposite effect on its surroundings. It would not pull matter in, but rather push it away. Anything that got close would be violently repelled, sent hurtling into space. So, instead of an accretion disk, a white hole would have a rejection disk, a region of space-time where matter and energy are constantly being pushed away, creating a kind of cosmic wind that blows against the incoming tide of the universe. The matter and energy that make up this rejection disk would not be falling in. They would be flowing out a constant stream of new material. This brings us to a fascinating scientific oddity, a subtle difference between the two that reveals their true nature. The black hole's gravity is a powerful force that works on everything from the smallest particle to the largest galaxy. This is the force that bends the river of time and creates the whirlpool of the event horizon. The white hole's repulsive force is not gravity as we know it. It is, in essence, a time-reversed gravitational force, a kind of anti-gravity that pushes instead of pulls. A white hole is a place where gravity is turned inside out. The immense pressure that is pushing matter out from the singularity is so great that it overcomes the universe's natural tendency towards gravitational collapse. This collision is a confrontation between these two opposing forces, the pull and the push. The black hole's gravitational field would warp space-time in a way that tries to pull the white hole in, but the white hole, with its immense repulsive force, would be pushing back, creating a region of space-time so turbulent and unstable that it would simply cease to be. The energy required to maintain this state of equilibrium, where the pull and the push are perfectly balanced, would be infinite. The universe, in its elegant wisdom, does not allow for such things. So what is the fate of these two opposing forces? One possibility is that the black hole's gravitational pull, being a known and observed force, would simply overwhelm the theoretical repulsive force of the white hole. The white hole, a phantom of the equations, would be swallowed whole, disappearing into the black hole's depths. But what would be the result? Would the black hole simply get bigger? Or would the paradox of the collision, a one-way street in meeting a one-way street out, create a new kind of singularity, one that is not just an end, but a source of perpetual conflict? Another more poetic possibility is that the white hole's repulsive force would be so powerful that it would prevent the black hole from ever truly consuming it. Their boundaries would meet, but they would not merge. They would be locked in an eternal struggle, a cosmic stalemate, where creation and destruction are forever battling. This would create a new kind of cosmic object, a binary system of black and white holes, locked in a perpetual dance of attraction and repulsion. This binary system would warp space-time in a way we cannot begin to imagine. It would be a cosmic engine of immense power, a source of energy and matter that would be constantly being created and destroyed in a perpetual cycle. This is a story about the boundaries of our knowledge and the elegance of the universe's laws. The truth is, we don't really know for sure. This raises an interesting philosophical question. Are these two entities so perfectly opposed that they cannot exist in the same reality? Is the existence of a black hole a place of finality? Proof that a white hole, a place of perpetual creation, cannot exist? Or could it be that they are two sides of the same coin, two expressions of the same fundamental force, and their collision is simply the moment where they are forced to confront their own duality? The story of the black hole and the white hole is at its heart a metaphor for the great struggles of the universe, life and death, creation and destruction, beginning and end. And their collision is the moment where these struggles are brought to a head, where the very fabric of reality is forced to choose a side, or perhaps to create a new one altogether. The dance is reaching its crescendo, and the moment of truth is upon us. The two titans, the black hole and the white hole, are no longer just approaching each other. They have made contact. Their event horizons, the one-way streets of their separate natures, have met. What happens at this boundary, this singular point in space-time where creation and destruction collide? This is where the story ceases to be about a collision and becomes about a conceptual death. What happens when an entity that cannot exist, the white hole, is forced to confront a reality that is its perfect yet impossible opposite? From a purely logical standpoint, the most likely outcome is the annihilation of the white hole. The black hole, a reality we have observed and measured, is a testament to the immense power of gravity and the elegant, if brutal, laws of stellar collapse. The white hole, a mathematical ghost, has no such physical foundation. Its repulsive force, its constant output of matter and energy, is a direct violation of the fundamental laws of thermodynamics. When it meets the black hole, the universe is forced to choose between a physical reality and a mathematical impossibility. And in the cosmic courtroom, reality always wins. The black hole's immense gravitational pull would simply overwhelm the white hole's theoretical repulsive force. The white hole, a concept that cannot exist, would be consumed, erased from the fabric of reality. But what does this conceptual death look like? It's not a fiery explosion. It's a profound, silent erasure. As the white hole's event horizon, its boundary of outward flow, touches the black hole's event horizon, its boundary of inward flow, the universe would be faced with a paradox so immense that it would simply break the rules of reality. The white hole would be forced to enter the black hole, a feat its very nature forbids. The immense pressure that is pushing matter out from the white hole would be met with an even more immense gravitational pull that is drawing matter in. The result would not be a new object, but a kind of cosmic cancellation. The The white hole, a place where matter is created, would be plunged into a place where matter is destroyed. The two opposing forces would negate each other, leaving behind nothing. This raises a profound philosophical question about the nature of existence. Can an idea be truly destroyed? Or does the conceptual death of the white hole simply mean that its energy and matter are not destroyed, but are rather converted into another form, a kind of cosmic ghost that haunts the singularity of the black hole? This is a question that physicists still wonder about. The information paradox of black holes, which we touched on earlier, becomes even more complicated here. If the white hole is a source of information, a fount of new matter and energy, what happens to that information when it is consumed by the black hole? Does it get lost forever? Or does it get preserved in some new exotic form? The truth is, we don't really know for sure. This collision is a story about the boundaries of our knowledge. We have a solid understanding of how black holes form and behave, but the white hole remains a beautiful yet baseless theory. When the two collide, our knowledge base comes up against a wall of pure speculation. We are forced to ask questions for which we have no answers. What happens to the universe's laws when they are violated in such a spectacular way? What is the fate of a theoretical entity when it is forced to confront a physical reality that it cannot coexist with? The most elegant answer is that the universe simply corrects itself. The white hole, a cosmic error, is simply rectified. It is erased, and the black hole, a cosmic truth, remains. This brings us to a fascinating and slightly strange scientific fact. Remember the Novikov self-consistency principle we talked about earlier? The idea that time travel paradoxes are impossible. The collision of a black hole and a white hole is the ultimate paradox. The white hole, being a time-reversed black hole, is an object that is in essence coming from the future. The black hole is an object that is moving into the future. When they collide, you have a situation where the future and the present meet in a single cataclysmic point. The Novikov principle would suggest that this collision is impossible, as it would create a time loop that cannot be resolved. The black hole and the white hole, by their very nature, would have to avoid each other, a kind of cosmic choreography where two perfect opposites can never meet. But we are here for the impossible. So let's go back to our moment of contact. The white hole's conceptual death is not the end of the story. It is the beginning of a new one. What if instead of being completely erased, the white hole's energy and matter are absorbed by the black hole, but in a way that fundamentally changes the black hole's nature? What if the black hole, the ultimate consumer, becomes a new kind of object? One that has been infused with the white hole's creative energy. This would be a place where the rules of reality are not just broken, but rewritten. The collision is over, or at least the immediate paradoxical moment of contact has passed. The white hole, that ghost of a concept, has met its end. But its death was not in vain. It did not simply vanish. Instead, its immense theoretical energy and matter were absorbed by the black hole. The devourer has consumed the giver. But what is the aftermath of such a cataclysm? This is a place where the rules of the universe are not just bent, but utterly shattered. The black hole, our familiar cosmic drain, is no longer the same. It has been fundamentally changed by the paradoxical nature of its meal. We are now in a realm of pure speculation, a place where reality is being rewritten, where the laws of physics are nothing more than a memory. The immediate result would be a wave of unimaginable chaos, a scar left on the very fabric of space-time. Think of the universe as a calm, still lake. The black hole is a massive stone dropped into it, creating a deep singular whirlpool. The white hole is a reverse stone and antistone that creates a geyser. Their collision is not two stones meeting. It is the whirlpool and the geyser trying to occupy the same space. The result would be a cosmic splash, a turbulence that would ripple across the entire universe. We would see gravitational waves of an intensity never before imagined, waves that would not just stretch and compress space-time, but would tear it, leaving behind a wake of pure, unadulterated energy. This would be the signature of the impossible, a cosmic scream that echoes through the universe, a testament to the moment when a physical reality and a mathematical impossibility met. This is a place where even the most fundamental laws, like the conservation of energy, might be temporarily suspended. Where did the white hole's creative energy go? Was it simply annihilated, or was it transformed? This is where the story gets truly strange. What if the energy of the white hole, a concept of constant creation, didn't simply disappear, but was instead absorbed into the black hole's singularity, fundamentally changing its nature? The singularity, once a point of infinite density and zero volume, a place of ultimate finality, might become something else entirely. It might become a pulsating core of paradox, a heart that is both a sink and a source, a place where matter and energy are simultaneously pulled in and pushed out. This would be a new kind of object, a hybrid, a cosmic chimera that defies all classification. This raises a fascinating and slightly strange scientific fact, one that is beautifully connected to our discussion of information. Remember the holographic principle. This is a theory in physics that suggests that all the information in a region of space can be thought of as existing on the boundary of that region. A black hole's event horizon in this context would be like a cosmic hard drive, a 2D surface that contains all the information of the 3D objects that have fallen into it. So what happens when the white hole, a source of new information, is absorbed by the black hole? Does its information get written onto the event horizon? Or does it fundamentally change the nature of the information that is already there? Could the white hole's information, a record of creation, overwrite the black hole's information, a record of destruction? This is a profound question about the nature of information and its preservation. The truth is, we don't really know for sure. The aftermath would be a universe in turmoil, not in a violent, destructive sense, but in a chaotic, unpredictable sense. The fabric of space-time would be torn and stretched in ways that we cannot begin to comprehend. The river of time we spoke of earlier would be a maelstrom with currents flowing in all directions. Our understanding of cause and effect of how things happen in a predictable order would be utterly shattered. This is a universe where the past and the future might be inextricably linked, where an event in the past could be influenced by an event in the future. This is a violation of the principle of causality, the idea that an effect can precede its cause. And yet here we are in a universe where the ultimate cause. Let's effect the white hole has just collided with the ultimate cause and effect machine, the black hole. This collision is a story about the breaking of mirrors. Our universe is a beautiful tapestry of predictable laws and elegant symmetries. The black hole is a perfect expression of these laws. The white hole is its theoretical mirror image. Their collision is like smashing that mirror. The beautiful symmetry is gone, and what's left is a fragmented, chaotic reality where the reflection and the original are no longer distinct. This is a place where the very concept of up and down, of in and out, of beginning and end has become meaningless. And as we float in the aftermath of this cosmic cataclysm, we are left to wonder what new laws, what new physics, what new reality will emerge from the chaos. The chaotic wake of the impossible collision continues to spread, rippling through the quiet fabric of our imagined universe. The black hole, now a paradoxical hybrid, is a new kind of cosmic object, and its influence on the cosmos is strange and unpredictable. Our story is no longer about a collision, but about the aftermath, about the new rules that govern a universe scarred by an impossible event. The most profound effect of this collision is that it has shattered the elegant symmetries of our universe, as if a beautiful mirror has been shattered, leaving behind a fragmented, chaotic reality. Remember the beautiful, predictable laws of physics, the ones we use to describe everything from the fall of an apple to the orbit of a planet. The collision of a black hole and a white hole has created a region of space-time where these laws no longer apply. This new paradoxical entity is a place where a one-way street in and a one-way street out have been forced to exist at the same time. This is a profound violation of the principle of causality, the idea that every effect has a cause, and the cause must come first. In this new broken reality, cause and effect are no longer distinct. An event could happen, and its cause could be in the future. This is a universe where a book could be written before the author exists, and a star could die before it is born. This is the essence of a broken mirror. Our universe, in its elegant symmetry, has a clear direction of time, a clear flow from past to future. The black hole is a perfect example of this. It takes in matter and energy from the past and moves it inexorably towards a future singularity. The white hole, in its theoretical perfection, is a mirror image taking in matter and energy from the future and moving it inexorably towards a past singularity. Their collision shatters this mirror, leaving behind a place where the distinction between past and future is gone. This is a universe where a single event can be both a beginning and an end, a cause and an effect all at once. This raises a fascinating and slightly strange scientific fact. Remember how we talked about entropy, the measure of disorder in the universe? The second law of thermodynamics states that entropy can only increase over time. A black hole increases entropy by taking in matter and making its information inaccessible. A white hole, by constantly creating and pushing out ordered matter, would decrease entropy. The collision of the two creates a region of space-time where the flow of entropy is no longer a one-way street. In this new paradoxical object, entropy could be both increasing and decreasing at the same time, a violation of one of the most fundamental laws of our universe. The truth is, we don't really know for sure. The collision would also create a new kind of gravitational wave, a kind of cosmic echo that would ripple through the universe. Unlike the gravitational waves we have observed from colliding black holes, these waves would carry the signature of a profound paradox. They would not just stretch and compress space-time, but would also warp the very direction of time itself. They would be a cosmic whisper of the impossible, a ghost in the machine that reminds us of the moment when the laws of the universe were broken. We could in theory detect these waves, and in doing so, we would be listening to the sound of a universe that is fundamentally different from our own. The aftermath of this collision is a story about the boundaries of our knowledge. We have a beautiful, elegant framework of laws and theories that we use to describe the universe. But this event, this impossible collision, is a place where that framework breaks down. We are forced to confront the limits of what we know and what we can ever hope to know. The new hybrid object is a place where our understanding of space-time and matter ceases to exist. It is a place where our physical laws are nothing more than a memory, and a new kind of physics, a new kind of reality is born. The story of the black hole and the white hole is a metaphor for the human condition. We are creatures of beginning and end. We are born, we live, and we die. We create and we destroy. The collision of these two titans is the ultimate expression of this duality, a moment where the two opposing forces of our existence are brought to a head. And in the aftermath of this collision, we are left with a universe that is no longer a simple, predictable machine, but a complex paradoxical tapestry of creation and destruction, of past and future, of beginning and end. The aftermath of the impossible collision has left us with a cosmic scar, a place where the mirror of reality is shattered. We have a new hybrid object, a paradoxical entity that is both a black hole and a white hole. Its event horizon is no longer a one-way street, but a kind of cosmic roundabout where matter is simultaneously being pulled in and pushed out. This is a universe where the rules are broken, and the most profound of these broken rules is the flow of time itself. The white hole, in its theoretical perfection, is a time-reversed black hole. So when matter and energy are ejected from its core, they are in a sense traveling backward in time. Now, when a black hole and a white hole collide, their time streams also collide. The black hole's arrow of time, a steady march towards a future singularity, meets the white hole's arrow of time, a steady march towards a past singularity. The result is a region of space-time where time no longer has a single coherent direction. This is a place where a particle's journey can be both forward and backward in time, a violation of the most fundamental principle of our universe. This concept of time reversal is one of the most mind-bending aspects of our thought experiment. In our universe, time is inextricably linked to entropy, the measure of disorder. The second law of thermodynamics tells us that entropy can only increase over time. A black hole, by taking in matter and making its information inaccessible, increases the entropy of the universe. A white hole, by expelling ordered matter and energy, would be a machine of decreasing entropy, a direct violation of this law. The collision of the two creates a region of space-time where the flow of entropy is no longer a one-way street. In this new paradoxical object, entropy could be both increasing and decreasing at the same time, a violation of one of the most fundamental laws of our universe. The truth is, we don't really know for sure what would happen to entropy in such a scenario. This also raises a fascinating and slightly strange scientific fact, one that is beautifully connected to our discussion of time. Remember the concept of the twin paradox in special relativity. If one twin travels at near the speed of light, while the other stays on Earth, the traveling twin will age slower. This is because time is relative, and its flow is influenced by speed. Now imagine a particle entering our hybrid object. One part of its journey is into the black hole where time slows down, and the other part is out of the white hole where time might be reversed. What happens to the particle's age? Does it get younger, or does it simply cease to have an age, its existence becoming a kind of timeless paradox? This is a question that our current physics cannot answer. The collision would also create a new kind of temporal paradox, a kind of cosmic time loop. Imagine an object that falls into the black hole side of our hybrid object. Instead of being destroyed at the singularity, it is somehow transported to the white hole side, where it is ejected back into the universe. But when it is ejected, is it ejected at a different point in space or a different point in time? What if it is ejected into the universe's past, and it is the very same object that falls into the black hole in the future, creating a perfect self-contained loop? This is a violation of the Novikov self-consistency principle, which suggests that such time loops are impossible. The universe, in its elegant wisdom, would have to correct this paradox. But how it would do that is a mystery. The story of the black hole and the white hole is a metaphor for the human experience of time. We are creatures that are constantly moving forward in time, a one-way street from birth to death. But we are also creatures of memory and hope, living in the past and the future at the same time. The collision of these two titans is the ultimate expression of this duality, a moment where the two opposing forces of our existence are brought to a head. And in the aftermath of this collision, we are left with a universe that is no longer a simple, predictable machine, but a complex paradoxical tapestry of past and future, of beginning and end. Our journey into the aftermath of the impossible collision continues, and we are now left with a universe that is no longer a simple, predictable machine. The black hole and the white hole, the devourer and the giver, have merged into a new kind of object, a paradox made manifest. This is not just a new cosmic entity. It is the dawn of a new reality, a place where the very laws of physics are not just bent, but utterly rewritten. What emerges from this chaotic core is a mystery, a profound question that lies at the heart of our story. What is this new entity? Let's call it the paradoxical singularity, a kind of cosmic heart that pulses with both creation and destruction. It is no longer a one-way street, but a two-way street, a place where matter and energy are simultaneously pulled in and pushed out. This is a profound violation of the law of conservation of energy, which states that energy cannot be created or destroyed, only transformed. In our new reality, this law has been shattered. The paradoxical singularity is a machine of perpetual creation and destruction, a cosmic engine that is both a source and a sink, a beginning and an end. This new entity would have a new kind of event horizon, a boundary that is no longer a simple point of no return. It would be a boundary of pure paradox, a place where the rules of causality are suspended. An object that enters this event horizon could be torn apart and its matter sent back out, but at a different point in time, perhaps even in a different universe. This would be a stable wormhole, a bridge through space-time that is no longer a one-way street. It would be a two-way tunnel, a kind of cosmic subway system that could transport matter and information to different parts of the universe, and even to different moments in time. This raises a fascinating and slightly strange scientific fact, one that is beautifully connected to our discussion of information. Remember the holographic principle, the idea that all the information in a region of space can be thought of as existing on the boundary of that region. The event horizon of our paradoxical singularity would be a new kind of cosmic hard drive, one that is not just storing information, but also creating it and destroying it at the same time. The information of the objects that fall in would be mixed with the information of the objects that are being pushed out, creating a kind of cosmic noise, a static that would be a testament to the chaos of the collision. The truth is, we don't really know for sure what would happen to information in such a scenario. The paradoxical singularity would also be a source of new physics, a place where our current theories would simply fail. The equations of general relativity, which describe the gravity of black holes, would be mixed with the theoretical equations of white holes, creating a kind of mathematical gibberish that would defy all attempts at comprehension. This new entity would be a kind of cosmic laboratory, a place where the universe is testing its own boundaries, creating new rules and seeing what happens. We would be a kind of cosmic scientist, watching this experiment unfold, trying to make sense of a reality that is stranger than fiction. The story of the paradoxical singularity is a metaphor for the human imagination. We are creatures that are constantly pushing the boundaries of what we know and what we can ever hope to know. We dream of a universe that is stranger, more beautiful, and more paradoxical than we ever thought possible. The paradoxical singularity is the ultimate expression of this dream, a place where the impossible becomes possible. And the rules are not just broken, but rewritten. The impossible journey continues, and our story is now one of profound dialogue. We have witnessed the birth of a new reality, a paradoxical singularity that defies all classification. But this new entity is more than just a cosmic object. It is a conversation, a philosophical dialogue between two ultimate opposites, the black hole and the white hole. Their collision was not a simple crash. It was a meeting of minds, a confrontation between two opposing ideas: existence and non-existence, creation and destruction, beginning and end. The black hole, with its immense gravitational pull, is a statement about the finality of things. It is the universe's ultimate eraser, a place where matter, energy, and information go to die. It is a powerful silent affirmation that all things must come to an end. It is the cosmic period at the end of a sentence. It represents the crushing weight of reality, the inevitability of decay and collapse. The black hole is a testament to the fact that nothing lasts forever. The white hole, in its theoretical perfection, is a statement about the perpetuity of things. It is the universe's ultimate creator, a place where matter and energy are born from nothingness. It is a furious, brilliant affirmation that all things must have a beginning. It is the cosmic capital letter at the start of a sentence. It represents the boundless potential of creation, the spontaneous eruption of life and light. The white hole is a testament to the fact that something can come from nothing, the paradoxical singularity. Our new cosmic hybrid is the result of their dialogue. It is a kind of cosmic and, a place where the period and the capital letter are forced to exist at the same time. It is a place where creation and destruction are no longer separate concepts, but are two sides of the same coin. The matter that is pulled in is the matter that is pushed out. The energy that is consumed is the energy that is created. It is a kind of cosmic Ouroboros, a serpent devouring its own tail, a perfect and impossible loop, where beginning and end are one and the same. This dialogue between opposites is at the heart of our story. It is a profound philosophical confrontation that transcends the physical and enters the metaphysical. The black hole says, all things are transient. The white hole says, all things are eternal. The paradoxical singularity. Their child says, all things are both. It is a place of ultimate duality, a cosmic yin and yang, where the two opposing forces of the universe are brought into a perfect, if chaotic, harmony. This raises a fascinating and slightly strange scientific fact, one that is beautifully connected to our discussion of duality. Remember wave-particle duality. This is a fundamental concept in quantum mechanics that states that every particle in the universe is both a particle and a wave at the same time. The electron, for example, can be a tiny particle with a defined location, or it can be a wave that is spread out over a region of space. The paradoxical singularity is a kind of cosmic wave-particle duality. It is both a singularity, a point of pure destruction, and a fountain, a point of pure creation at the same time. The truth is, we don't really know for sure how such an entity would exist in our universe. The story of the black hole and the white hole is a metaphor for the great struggles of the universe, life and death, creation and destruction, beginning and end. Their collision is the moment where these struggles are brought to a head, where the very fabric of reality is forced to choose a side, or perhaps to create a new one altogether. And in the aftermath of this collision, we are left with a universe that is no longer a simple, predictable machine, but a complex paradoxical tapestry of creation and destruction, of past and future, of beginning and end. We have journeyed to the heart of a paradox, and now we must look beyond it to the grand cosmic cycle of which it might be a part. The collision of the black hole and the white hole, the birth of our paradoxical singularity, is more than a one-off event. It is a profound meditation on the concept of cosmic recurrence, the idea that our universe is not a singular event, but a part of an eternal repeating loop. The universe, in this view, is a cosmic serpent devouring its own tail, a story that is being told over and over again from a different beginning to a different end. Remember the story of the black hole's birth, the death of a supermassive star. This is a cycle of life and death, of creation and destruction. Stars are born from vast clouds of gas and dust. They live their lives in a blaze of glory, and they die in a spectacular supernova explosion, leaving behind a black hole. This black hole then consumes matter, growing larger and larger, a tomb for all the things that fall into it. But what if this tomb is also a cradle? What if the matter that falls into a black hole is not destroyed, but is simply reborn, not in our universe, but in another? This is the core idea of cosmic recycling, the notion that the end of one universe is the beginning of another. This is where the white hole, our theoretical giver, comes back into the story. What if the white hole is not a separate entity, but the other side of a black hole? What if the matter that falls into a black hole in our universe is ejected from a white hole in a different universe, creating a kind of cosmic wormhole, a bridge between two realities? The paradoxical singularity. Our new hybrid object is the physical embodiment of this idea. It is a place where the end of our universe is the beginning of another, a cosmic doorway that connects creation and destruction in an eternal loop. This raises a fascinating and slightly strange scientific fact, one that is beautifully connected to our discussion of cosmic loops. Remember the Novikov self-consistency principle, which suggests that time travel paradoxes are impossible. In a universe of cosmic recurrence, this principle is taken to its logical extreme. The universe is a perfect, self-consistent loop. The end of one cycle, the formation of a supermassive black hole, is the cause of the next cycle, the birth of a new universe from a white hole. There is no beginning or end, only a continuous loop. This is a universe where the past, present, and future are all happening at the same time, a kind of eternal now, where all of our cosmic stories are being told over and over again. The truth is, we don't really know for sure if our universe is a part of such a loop. The story of the collision of the black hole and the white hole is at its heart a metaphor for the great struggles of the universe, life and death, creation and destruction, beginning and end. Their collision is the moment where these struggles are brought to a head, where the very fabric of reality is forced to choose a side, or perhaps to create a new one altogether. And in the aftermath of this collision, we are left with a universe that is no longer a simple predictable machine, but a complex paradoxical tapestry of creation and destruction, of past and future, of beginning and end. This is a story about the boundless potential of the universe, a story that is being told over and over again in the quiet dark of space. Our journey is drawing to a gentle close, and we are left in the quiet aftermath of the impossible. We have witnessed the collision of two cosmic titans, the black hole and the white hole, and from their impossible meeting, a new reality has been born. This is a story about the ultimate unification, a profound meditation on how the most opposing forces in the universe, creation and destruction, could, in the end, be two sides of the same coin. The paradoxical singularity. Our new hybrid object is a physical embodiment of this dream, a place where the devourer and the giver are one and the same. In our universe, we see duality everywhere. There is life and death, light and shadow, beginning and end. We are a part of these dualities, living our lives in the space between two opposing forces. The black hole and the white hole are the ultimate expression of this duality, a cosmic yin and yang. The black hole is the embodiment of the end of all things, the finality of existence. The white hole, in its theoretical perfection, is the embodiment of the beginning of all things, the perpetual motion of creation. Their collision is the moment where these two opposing forces, these two ultimate ideas, are forced to confront each other. And in that confrontation, they do not destroy each other. Instead, they merge. They become a single entity, a place where creation and destruction are no longer separate concepts, but are two sides of the same coin. The paradoxical singularity is a new kind of cosmic object, a place where the universe is both being created and destroyed at the same time. It is a place of ultimate balance, a kind of cosmic equilibrium where the two opposing forces of the universe have found a new kind of harmony. This is a story about the profound truth that in the universe, nothing is ever truly destroyed, only transformed. The matter that falls into a black hole is not lost forever. It is simply reborn, not in our universe, but perhaps in another. This is a profound question about the nature of the universe. Is it a simple linear story with a beginning and an end? Or is it a grand eternal loop, a cosmic serpent devouring its own tail, where the end of one story is the beginning of another? The collision of the black hole and the white hole is the ultimate expression of this idea, a moment where the two ends of the loop are brought together. And in that moment, we are left to wonder if our universe is just one of many, a single bubble in a vast cosmic foam, and the black holes and white holes are the gateways that connect them all. This thought experiment, this impossible journey we have taken together, is a testament to the power of human imagination. It is a story about how we as a species are constantly pushing the boundaries of what we know and what we can ever hope to know. We dream of a universe that is stranger, more beautiful, and more paradoxical than we ever thought possible. The paradoxical singularity is the ultimate expression of this dream, a place where the impossible becomes possible and the rules are not just broken, but rewritten. It is a place where we are forced to confront the limits of our knowledge and to embrace the mystery of the cosmos. The story of the black hole and the white hole is a metaphor for the human condition. We are creatures of beginning and end. We are born, we live, and we die. We create, and we destroy. The collision of these two titans is the ultimate expression of this duality, a moment where the two opposing forces of our existence are brought to a head. And in the aftermath of this collision, we are left with a universe that is no longer a simple predictable machine, but a complex paradoxical tapestry of creation and destruction, of past and future, of beginning and end. The beautiful, elegant framework of laws and theories that we use to describe the universe is not broken by this event. It is simply transcended. The paradoxical singularity is a place where our current physics is not wrong, but incomplete. It is a place that reminds us that there is always more to learn, more to discover, and more to dream. It is a place that tells us that the universe is not just a collection of particles and forces, but a living, breathing story, a story that is being told over and over again in the quiet dark of space. The collision of the black hole and the white hole is a profound question about the nature of the universe. Is it a closed system, a book with a finite number of pages? Or is it an open system, a story that is constantly being written with new chapters and new characters being born from the ashes of the old? The paradoxical singularity is the ultimate answer to this question, a place where the universe is both a closed loop and an open-ended story, a place where the past, present, and future are all happening at the same time. It is a place that reminds us that the universe is not just a machine, but a mystery, and it is a mystery that we are a part of. This is the end of our journey, but it is not the end of the story. The story of the universe continues to be written, and we are a part of it. We are the conscious observers, the curious minds that dare to ask the impossible questions. We are the dreamers, the poets, the scientists who look into the dark of space and see not just a void, but a canvas for a new kind of cosmic poetry. And so, with a quiet heart and a mind full of wonder, we return. And so our impossible journey comes to a gentle close. We have ventured to the edge of what we know and gazed into the heart of a paradox. We have watched as the laws of the universe were bent and broken and new realities were born. But now it is time to return. The cosmic winds are slowing the chaotic ripples of our thought experiment, are fading into the silent dark. It's time to let the grand impossible dreams of black holes and white holes slowly dissolve from your mind. Let them gently brush past your awareness like a whisper in the night. The journey is over, but the questions remain floating in the peaceful void. I'd like to gently ask one last time, where is the place you're staying now? The time in that place at this very moment, how is it flowing slower or faster? The same or different, whatever the answer. Know that you are a part of a beautiful, impossible universe. Before you drift off, just a reminder to consider giving this video a like and subscribing if it made you feel even a little more at peace. But no worries if not. Sleep well, my companion, wherever and whenever you are. Sweet dreams.